So I'd like to begin this session with an interesting thought from Erno Rubik. I don't know how many of you already know about Rubik, but you must know about the three-dimensional combination of puzzles of Rubik's Cube. So he had once said that if you're curious, you'll find the puzzles around you, and if you're determined, you will solve them. So I believe the business of IoT will reap great benefits to curious minds, who can catch this technological paradigm when it is still young and forgiving. So, IoT actually potential IoT hides the potential in plain sight. So you need to have a curious eye to actually uncover it. So that's why I thought I'll just begin this discussion on this interesting thought by Arno Rubik. So as you can see on the screen, this is an appetizer discussion. This is just to whet your appetite about IoT. Some of you might already have heard about it. Some of you might be already working on it. You might be aware of some aspects of it. However, the agenda today is to get you formally introduced you to this phenomena called IoT. The path is the idea is to have a structured and a formal introduction to the world of IoT. And our discourse today might meander into both business and technological territories. So when I see our and us, I essentially mean, and I'm made to understand that today we have three kinds of audiences. Some of us are starting entrepreneurs who are wanting to explore the world of IoT from an entrepreneur's perspective. Some of us, I believe, are either business graduates or business graduation aspirants who might join business roles in a company that is undergoing IoT based digital transformation. And last but not the least, the developers, so who have all the expertise in the coding arena, however, would like to contextualize their understanding by knowing the end-to-end solution and how it is being used in the real world. So those are the people that would really benefit. So if you are not in these three boats, then you have to figure out what you really learn from this webinar in a different way. But these are the three key target audiences that I would like to address today. So let's go through the discussion. I hope the slides are changing as I'm speaking. If someone can confirm, that'll be great. Okay, great. So the proposed discussion of today is we'll basically begin by boxing the IoT into the boundaries of a definition. Then we'll rather unbox and break it open and look at it from a solution and a business lens, and how we drive value out of it as an entrepreneur, as a business leader. And then we should also look at, when we look at it from an entrepreneur's perspective, where should one invest his energies in? What should be a build versus buy decision for each of those components? And then when you operate in an IoT world, what are the ways of working that have changed? That's an inside-out view of an organizational perspective. And then we quickly conclude with crystallized learnings about all these aspects. So let's dive right in. So when we begin to understand anything, I'm kind of a firm believer of this thought by Winston Churchill when he said, "The farther backward you can see, look, the farther forward you can see." So I think it's very essential that we take our learnings from the history. And when we look at the past of the landscape and the ecosystem that we live in, we see paradigm shifts. A paradigm shift is a profound and almost an irreversible change in the way of thinking and doing things. So, though we always tend to get comfortable with status quo, but history is always replete with periodical paradigm changes. So, the graph on the right actually signifies how the industry sticks to a given technology only till the time its incremental innovation justifies the sunk costs. So then at the point of inflection, you see it adopts to a new technology. And that is what we should be wary about. That is what we should be careful and be attentive to in the industrial landscape that we live in today. So and this is the change that we are all trying to perceive. All the customers that I speak to, all the business leaders that I speak with here, everybody is the same question as to how is their industry transforming and how can they leverage it. So IoT is a particularly convoluted topic because it is actually a confluence of multiple paradigms converging together. So, although I'm just mentioning here two dimensions, compute perspective and connectivity perspective on the screen, but actually everything is undergoing a similar change. For example, application architecture is evolving from monolithic to microservice-based architecture. Databases are moving from relational to HDFS. Server client architecture is moving to serverless architecture. So basically we get the idea that just from two dimensions we're trying to see that a lot of changes happening in multiple dimensions, and they're converging into this paradigm called IoT. So although I'll not go into detail of how this compute has changed over time and how connectivity has changed, but essentially the key point is that compute has become powerful, cheaper, and accessible. Sensor prices are dropping. The foundry manufacturing, which manufacture the system on chips, are now talking about 14 nanometer transistors, which used to talk about 180 nanometers just like 5 years back, or maybe 7 years back. So considering this change is continuous, it shouldn't be taken as a surprise that we'll continue to change at this fast pace. But the challenge is to adapt to this fast pace when everything is changing. For example, now you see ubiquitous connectivity with 5G speeds, reducing cost. The way we interact with machines in AR, VR has changed. So all these converge into the Internet of Things, and that is where we need to understand, that how can we see opportunities when all of these converge together? What opportunities are hiding in the plain sight? So that takes me to my next slide, where we, before understanding those opportunities, we put this IoT into a definition. So, although the Internet of Things is sounds like a hot new topic, but it's actually not a new concept. It was actually introduced by this gentleman whose picture we see, Kevin Ashton, in early 2000s. And he was actually working for Procter and Gamble, and he was trying to figure out ways in which everything can be connected together via RFID, and that can be used to reduce costs. And I think, although I see a lot of definitions today from IBM, Cisco, Microsoft, but his definition, I personally feel, is most comprehensive and complete when he says that if we had computers that knew everything there was to know about things, using data they gathered without any help from us, we would be able to track, count everything, greatly reduce waste, loss, and cost. I think he covers AI here, he covers analytics here, he covers ubiquitous connectivity here. So I think it's a very, very beautifully crystallized definition, and that's what I usually go by. So this is the definition that he actually published in the RFID journal in 1999. You can feel free to put in your doubts or queries in case you have any while we're going through this. So that's how Kevin Ashton defined Internet of Things, you know, and and I would like to say that it's now at this stage. So what we've done so far is understood the definition of it. At this stage, it's very important to know why it is important to know IoT. So please confirm if you can see my screen, because I see half of the screen not coming out clearly. Okay. Uh, so the various aspects of our life which IoT is actually affecting, you will understand the comprehensiveness and the ubiquitousness of IoT. If we start from smart retail, think of an integrated kiosk, digital signage, point of sale system, supply chain software, working as one entity, giving the business an opportunity to enhance the customer experience, optimize costs at the same time. That is IoT. If you look at manufacturing in industries, the use cases can be actually categorized into two. One is inside factory and outside factory. Inside factory, you can have use cases which are product related or production asset related. For example, asset temperature monitoring, asset movement monitoring. I've personally seen some very interesting examples where a corkscrew was costing like 700 pounds, and we put an NB-IoT chip and sensor on top of it, and the business case made sense in like less than 6 months break even. So they're very interesting, profitable avenues to use IoT in manufacturing. So similarly, you could have a an outside factory car tracking system, right? Onboard diagnostic system. So you could have extend the idea of manufacturing outside factory as well. When you go to smart buildings management, I think digital home automation is one of the hottest use cases within the IoT ecosystem. In agriculture, the world changes. There's a hot debate about the kind of sensors that can be used for nitrogen, phosphorus, and potassium sensing in the soil. There's a great debate about the kind of sensors that have existed, but how can we make it better? So that's an avenue, an opportunity for the entrepreneurial mindset people to look at these problems and help the industry solve it. Yes, so that's a slide I'm on. Why is it important? Although my slides have vanished, but I believe all of you can see. So that's not a problem. So so we look at all these use cases. We look at the medical. Last but not the least is the usage of IoT. It can be revolutionizing in the medical field as well. So the reason that IoT is important is not only because it touches so many aspects of our lives in our professionals and our home environment, but also the kind of scale that is supposed to take up. It's supposed to take up scale of $1.2 trillion by 2021, maybe, and 20 to 25 billion devices. So that's the kind of scale. That's how it will become ubiquitous. So I see some questions coming up. So NB-IoT, yes. So that will come up in the subsequent slide when I kind of uncover this box from a solutions perspective. So basically, so far we've seen the definition of IoT. So we have seen, the journey in terms of the paradigm shifts. But so let me kind of quickly jump on to the unboxing of this or uncovering of the IoT box. So basically, if you look at the IoT box, you see these are the four key components that peep out of the box. One is a device which has a sensor, which might have a compute as well. There might be a gateway with it. Then these gateways are supposed to be connected to IoT platforms and databases at the back end. And on top of which, there can be an vertical specific or a horizontal application. And all these are binded together by a connectivity layer in which we have multiple options of connectivity for this. So let's have a closer look at each of these components, and we'll come across the terms like NB-IoT and what technologies can we take up. So moving on quickly to look at various choices within the IoT solution. So I'll request you to look at this slide from left to right. So if we look at the devices and the sensors, we see there are a host of options. For example, if you have a location-based IoT use case, you might want to use tags and anchors-based solution. If you have a proximity-based, RFID-based solution, if, for example, in a smart retail shop, that might make more sense. In an industrial environment, an actuator PLC might make more sense. You might want to use an infrared camera for capturing motion within an industry when a product is moving. So there are lots of use cases, and you have specific devices that suit those use cases. From a sensors perspective also, whether it's an infrared sensor, a chemical, a medical, it really depends upon the use case. Now, there are two options via which these devices can get connected to the backend. One is they connect to a gateway via short range technology, or the other is they connect directly to a wide area network technology. That's low power wide area network. So I'll come to those. From a short range technology perspective, as you can see, there are multiple options: HART, Profinet, IEEE 802.11 based technologies, Zigbee, Bluetooth, and there are really few factors on which you define as to what will be the choice of technology. Factors like range, power, throughput, latency, cost, band of operation, security. These are the kind of things that help you define as to what should be your technology of choice. The second option by which they connect through a low power wide area network, you can have multiple options. Again, there you can have a licensed band LTE or an LTE-M or a narrowband IoT or a 5G based system or LoRa and Sigfox. The difference is some of them operate in licensed band, for example, LTE, LTE-M, NB-IoT, and some of them operate in unlicensed band, for example, 802.11 LoRa and Sigfox. These typically operate in ISM band. For example, LoRa operates in 898 megahertz in some regions of the world. NVIT operates in the 2G spectrum, and LTE-M operates in the 4G spectrum. So Sigfox has very low throughput. It talks in bits per second. LoRa can do slightly better. 802.11 has multiple options, like it has A, B, G, N, R. And AX is coming up. So there are like host of options here to choose these technologies from. And this IoT gateway then can connect back again to the platforms using a wide area network. That's always an option. Now, sometimes based on the context, some of these backend networks are backend components are placed within the premise of the customer, and that's what is called as the edge compute. So you might have the core, a downsized core of a communication network lying within a private LT network, for example. Within the edge, we can call it compute. In manufacturing kind of scenario, you might have the systems that I've mentioned here: SCADA systems, HMI, human machine interface systems, or distributed control systems, or also lie in the same vicinity, and that's why they also can be termed as edge compute. And these then again connect back to the IoT platforms. Now, the way I look at IoT platforms is in two categories. One are the key functional capabilities that can come from one vendor or multiple vendor. It really depends upon what you're talking about. And then there are vertical specific application, which you see in the right box. So if you look at these applications, they essentially, we're talking about the capabilities. We're essentially talking about analytics platforms, service enablement, application enablement, connectivity management. So all these platforms, there are some vendors which are giving an end-to-end platform. For example, Azure, Microsoft Azure is giving, AWS IoT is giving those kind of solutions. I think Cumulosity from Software Edge is giving similar solutions. But there are some companies which are specializing in one of these platforms. For example, IBM has IBM Watson, which specializes in analytics platforms. And then you have certain companies that are coming up with pure play applications. And mind you, each of these platforms is in itself a subject. For example, device management, you can choose multiple protocols, lightweight M2M or TR6. There are a host of protocols you can choose. On application level, you can choose again host of protocols, AMQP, MQTT. So basically, you want to drive a pub sub model, a publish subscribe model, or a request response model of HTTP. So there are really host of decisions to be made and host of factors to be considered. I see some question: would the sensors have long battery life? So yeah, so it really depends upon the battery requirement. The typical battery life that is being projected right now is 8 to 10 years, but it's only limited to the cases of low power wide area networks such as LoRa, Sigfox, and NB-IoT, not LTE and LTE-M. And these LoRa and Sigfox are they're like the number of messages that they can send during a particular time interval is very less, and the latency is not committed at all. So that is the kind of trade-off that we are having. Are telcos providing IoT gateways and IoT platforms? So telcos have IoT gateways and platform, but they are being procured by other companies. So in the slides that are subsequent to this, I will explain the value chain and explain which part of this is being procured from which companies and what is the right decision to make, where can an entrepreneur or business leader add value, and where he should just, it's a commoditized product, just buy and move on. So we'll come quickly to those. So let's ride into that. But the real idea what I really want to discuss here in these the one slide that we see right now and the next one is, as a business leader, as an entrepreneur, when you look at IoT and its components, where you should think about buying and where you should think about building. How can you think about building your own USP, your IPR? And if you're thinking about buying, then what are your evaluation factors? How should you decide about that? So those are the kind of questions that these points mentioned on the slide will give you a bit of a direction to. Obviously, it's a very detailed topic and we'll need much more discussion to understand your specific use case or your specific idea. So let's begin with the devices part. So devices, it's a very capital intensive arena, building devices. Just 1 minute, please. Yeah. So devices, it's a very capital intensive process. The products are rather simplistic and they're mature with very little scope of innovation. So, and existing product companies have scale, they have global innovation, they have global distribution capability. So in my view, I'll recommend that one procure these from global suppliers and move on. It's very hard to add value there. But if you go to the gateways, that's by far one of the most interesting areas in this arena. It's a gateway essentially has a power module, a processor, a memory, a comms module, which are all easily available. Just like you assemble your computer, you can do that. You have and you have all the options of how much power, what processor speed, how much memory, what kind of communications, right? And it has very low barriers to entry to make these solutions, but at the same time the problem is that it's easily imitable. So going just by these two aspects, one should think that this should not be an attractive area for developing a unique selling point. But the story is really, it really begins at the point where we talk about the potential to innovate in the way the client software is implemented in here. You know, all the verticals would need a vertical specific customization of the gateway software. That's where you can add value. That's where you can be unique. That's something that cannot be imitated that fast. So another reason for building your own gateway is that it's going forward towards the direction of edge analytics, and edge analytics is in early stages, and we all know that data is something that's going to be the oil for the next maybe 50 years. And once you develop your self-learning and deep learning models, I mean, it'll be very hard for any competition to beat you. That makes this area very, very interesting. Quickly hopping on to the connectivity. So I don't think a lot of investors are keen on investing in licensed ICT infrastructure. However, there are two things that are happening there that are interesting. One is that a lot of new MVNOs focusing on IoTs are emerging, for example, Aries Communications. And secondly, there are new investors who are setting up low LPWAN networks in unlicensed band. The LoRa networks, the Sigfox networks. So these are the two areas where you can look at. And the opportunity for you as a business leader, as a technocrat, as an entrepreneur is that a lot of these are not standardized technologies. That means there will be a lot of error in the way it is being built as you move along. And that's where you can develop a more mature system and have a competitive advantage among your competitors. So I think these are the two arenas, where you can think of. One is developing this optimal software for the unlicensed open source technology. Second is also the way you engage with MNOs and MVNOs. I mean, you really cannot think the innovative and the creative business model that operators worldwide are thinking today. Vodafone has Vodafone Global SIM. Then there are other vendors, for example, Globecom, which is coming up with its own very interesting offers. It is tying up with all the operators in the world and creating one network by putting its core in different arenas. AT&T is putting its core only in Europe as well. So there are a lot of things happening in that space. You need to really talk to those operators and get the best out of the situation. Very quickly, moving on to the IoT platforms perspective. So although there are more than 400 platforms, but I still believe that IoT platforms in oligopolistic market structure, basically meaning there are only few players, because I think there are only 20 or 30 players that are leading the market, and they have a lot of market power. So I think one should be very, very careful about the price control that these guys can execute at a subsequent stage. Today, you will see Microsoft offering $25 per month for 400,000 messages per day kind of offer. I also heard about two 2 terabyte storage offer that came today from I think Oracle. Obviously, this is not confirmed, but these are news that I heard. But the key message is that it's an oligopolistic market, and one needs to be careful. However, there's an extension to this market where the open source market platforms are coming up, and that is where the build versus buy debate really heats up. So you need to kind of think through that. If you go for a build using open source software, then you don't have the time advantage, and you don't get off the shelf secure available products to try and fail fast and innovate fast. But in the long run, you have better control over your costs. So those are the kind of trade-offs that we need to kind of make intelligent decisions about. IoT applications are as interesting. Applications like pure software, so they're as interesting as applications in any other arena. There's nothing special about IoT in that place. It's just that scale is going to be much more than what we usually have. So quickly going to inside the organization, um, when as a business leader, think of it that you've taken that journey, you've decided what strategy to take, how to procure each component of those IoT systems. Then you need to also look at and learn how the ways of working of an organization need to change in the arena of IoT. So I mean, I know we're running short of time, so I'll very quickly go through this one. From a business perspective, um, I think the one thing that's very different is that we need to learn to cooperate with all the ecosystem players. Although it's a new industry, but it is not possible to be vertically integrated because it is so heterogeneous in nature. So that's why the business leaders need to know that they need to work together with the ecosystem rather than walking alone. That won't be possible. And the second is you need to have a very, very clear data strategy, because that is what will give you the real advantage, the value, rarity, inimitability, and non-substitutability. So that's what is very important from business perspective. From operations perspective, there are challenges like interoperability, evolving standards, data security, but I think they're all solvable, and that's something that I don't treat as really something that really is a showstopper. From technology perspective, there are multiple regulators. You'll have in smart energy, you'll have an energy regulator, a telecom regulator, a device regulator, and a host of regulators. Similarly, multiple standardization bodies, multiple open source initiatives. So to work with the right ones is that decision, I think, is the toughest from a technological standpoint. So overall, I'll say that developing IoT products need to be a cross-functional initiative within the organization and an ecosystem play outside the organization. So quickly crystallizing the couple of learnings that we can kind of take home with ourselves. From an external perspective, it's an evolving value chain, right? And demand is in early stages. We need to be very, very clear as to what do we want to do. I come across a multitude of organizations which are trying to do too many things in IoT and kind of find it hard. So my recommendation usually is that you need to focus on one particular use case. You need to put in a lot of research to figure out and earmark that use case, but then you need to focus on that one. Similarly, business models are evolving. As I mentioned, we need to be very, very creative about our engagement in terms of how do we engage with business models. And from an internal perspective, have a multidisciplinary approach within the organization, establish a clear data strategy, design an IoT innovation framework, fail fast but not randomly. So just because of paucity time, so that can be a full topic in itself, a debate for another day. So I hope that the three key candidates that I thought I'll add some value to today, the fresh business graduates and the aspiring IT entrepreneurs and the developers, take away something from this express session overall. I'll just quickly address some of the questions if I can. I don't know about the time. Let's see, what are the key skills to learn to be a developer? So it really depends, really varied. But I think the one that kind of hitting the ground running is Python as a development language. That there are a host of applications being developed in Python. Then, but I think it really depends upon you're talking about the front end, the back end, right? So if you talk about the way front end, I think it's more towards Python because it's the gateway coding that's happening. But at the application end, it's everything that's happening in the application world. So there's nothing specific about IoT from a back end perspective. The one thing specific is that the protocols are different. For example, in IoT, you will come across MQTT kind of AMQP kind of protocols. So those are brokers come from companies like Rabbit or Mosquito. So those are kind of brokers you need to have in the mix. That's slightly different, but that's all about connecting to those devices. Other than that, the way we have Kafka, the way the whole architecture is evolving, all that will remain same in IoT world as well. The way Netflix architecture is, or the way YouTube architecture is, or the way LinkedIn architecture is. I think that's remain the same. I think key skills similar. How long will it take ecosystem and partnerships to evolve? Well, that's anyone's guess. I think this is a very generic question. Maybe what we can think about is in terms of timeline, which use case will come up the fastest. So I think though there's a lot of innovation going around connected cars kind of use cases, but and different geographies have different verticals. So in Australia, if I talk about, I think construction industry has a great potential. It is there's a way to kind of measure it, Keshav. Uh, the industry which can to which digitalization can add maximum value is the one which might adapt to it the fastest. So in Australia, the construction industry is really manual, it's really unorganized, and it can do a lot of automation and reduce a lot of costs there. So that there I see a great potential. In Australia, again, smart agriculture is coming up in a big way. Smart mining is coming up in a big way. Healthcare is big. So these are the top four verticals in Australia. It's a very region specific thing as to which one have the most potential, then which one of them are least automated, then which one of them have government stimulation, for example, smart energy, smart water. So host of factors. But you need to come up with a particular specific conclusion for a specific region there. So thank you. Smart cities. Smart cities again a very wide topic because it includes smart environment, connected transport, and these all will have their own trajectories of growth. The one that I think from within the smart city ecosystem that's evolving the fastest is the smart energy and smart buildings. That ecosystem is relatively most mature with other ecosystems and has the attractiveness from an investment perspective because the government is rolling out those tenders. So that makes it a rather fast growing sector. So I believe I've overshot my time. So I think I'll hand it over to. Oh, okay. I think I'll have to conclude the session then in that case. Thank you very much all for joining the session. I hope you all took away something from the session. It was very interesting for me to talk to all of you. Thank you. Bye bye.